feel free to put it in the chat, that when we say AI ready data, what comes to your mind first? Just want to do a random survey to set the tone.
And can everyone see the screen okay? Yes, okay. Great. Well, thanks everyone for joining today. As Amy mentioned, my name is Sarah Marquise. I'm the Research Data Manager with Harvard University's Faculty of Arts and Sciences in the Research Computing Group. And I'm joined by my colleague Monaspita as well. And we will be talking today about AI-ready data. So we thought we'd start off with some AI in the news. So we're all continuing to receive a deluge of information about AI, both positive and negative on a daily basis. It's a heavily used buzzword, and scholars and researchers are continuing to focus on the impacts and the importance of AI. On the slide are several news articles kind of pulled together to show that range of positivity and negativity, from exciting new ventures like the one that's happening here in Massachusetts to build a new AI hub. So we're hoping to have homegrown research and development for research institutions and for private companies here in Massachusetts. There's also the negative stories that talk about the impact of AI data centers on minority groups and the environment. So it's a wide plethora of articles. And it's still kind of an unknown thing, right? Companies are pouring huge amounts of money into AI. Research institutions are investing in it. But is that investment paying off? I think time will tell, but we're still kind of in the middle of the AI bubble. So starting off with some positives, there are a number of benefits of AI for research. It can help with data analyses by speeding up repetitive processes and improving efficiency and reducing human error. It can also support academic writing. So it provides ideas, organizational suggestions, and offers tools to help with editing and citations. It can streamline your data curation efforts, systematically reviewing large amounts of data that would otherwise be unwieldy for a human to go through. It's great at predicting long-term models or trends using machine learning techniques. And the availability of AI tools for research has really abounded. There are a number of tools that are very focused on specific disciplines now, like AlphaFold and alpha geometry. So there are a lot of ways that AI can assist research endeavors. But there are also a lot of risks, right? So we've all seen those videos circulating around social media that show the limitations or inaccuracies of AI. One of the more recent ones that I saw focused on the number of R's in the word strawberry. So there are a lot of problems that we see, including a growing dependency from researchers and students on using AI tools like chatbots without fully understanding how those tools are pulling that information or whether or not it's accurate. There's also a lack of awareness around data privacy and security concerns, as well as ownership of intellectual property. So we've actually heard of faculty members that really aren't thinking about what they're doing when they're uploading things like preprint materials to AI chatbots. So they don't really think of the ramifications of uploading unpublished research to AI tools. We've also heard of students that are using AI chatbots to assist with writing their papers, and then they inadvertently or overtly plagiarize other people's works. There's also the unconscious bias that is now getting injected into research, as well as outright hallucinations, again, like the example of the spelling of the word strawberry. So there are positives and negatives when using AI with research. So now I'm going to pass it off to Manasvita, who's going to talk about what is AI ready data, what are some key characteristics of AI ready data, and how you can actually do it yourself. So go ahead, Manasvita.
Thanks, Sarah. So as Sarah already pointed out, that there are positive and negative sides to the use of AI. And I don't think it's possible to completely mitigate the negatives, but we can try to do our best to mitigate it as much as possible. And I think the first step towards that mitigation is your data preparedness, how ready it is for use in AI. So I'm so glad that I brought up this question with you all. Um, because looking at your answers, I can already say that when I started thinking about AI ready data, a lot of those things were here and there. And then as I started reading more, I could see that some of the terminology we might think that we don't need to think about, but those are actually very important points in thinking about AI ready data. So for example, just like any data, even if you want to use it for your regular analysis, it has to be a good quality data. It has to have a high quality so that it gives you a relevant result, right? But when you start thinking about AI ready data, there are multiple layers to it that go beyond high quality. So, just to give you a short synopsis of what at least I think AI ready data encapsulate is, it has to be high quality. It obviously has to be clean and has to have a structure. A structure in this case, specific to AI ready data, is something that is beyond tabular. And you will see, I'll try to make a point of how the documentation or text has made its way in all kinds of forms that can be used for AI use. Then it needs to have a data governance compliance element to it. It should be presented in a way that it is easily consumable by AI systems so that you're able to train and infer on it faster. Okay. And then because this is for an AI use, it has to have the right context and metadata attached to it, because as you would see, there are cases where if you don't give the right context, you don't get the right response. It should be stored in a standardized format which is suitable for either your research group or your institution or the organization that you're working at. Now, this in a way becomes a bit specific to AI readiness, because you have to think about your organization needs or your research needs or the problem at hand, and then think about how to standardize the format for that data. And then, of course, goes without saying that it needs to be aligned with the problem at hand that you're trying to solve, so that you can determine its accuracy and efficiency. So you need to have the question in mind that you're trying to answer. And when you are trying to answer that question, what it means to have the right answer, you need to know that also in order to determine that how to get your data ready for AI. So if you don't take anything else from these slides, the main takeaway you can take is from what I've highlighted here is think of AI ready data as an almost ML ready data, which means it should be complete, it should be consistent, it should be unbiased. It could have some features which you will usually expect for an ML ready data, but beyond that, it has additional layers, which is it needs to have relevant context and it needs to have a definition of what looks good, what is the good answer, or what is the right answer. So definition of good. Let's leave it at that. So all these components need to be put together for an AI ready data. Okay. And then once you have that, it is possible for an organization or a research group to really come to depend on it, because it then becomes a necessity if you're trying to get the most value out of your AI efforts. Okay. Next slide. Thank you. So now that we have some idea of what AI ready data means, the next question is, how do we achieve it? So the first, this is sort of like in multiple steps, but the very first thing that should come to your mind is you need to know the data story. You need to know where your data is coming from. So of course, you need to have the problem at hand that you're trying to solve. But in addition to that, you need to understand where your data has originated from so that you can curate it and clean it accordingly, right? Sometimes if a data, for example, has outliers and you just decide to take away those outliers, that may be a problem when you're trying to solve or answer a question that might have benefited from having those outliers in your data set. So you need to really understand not just the problem, but the origins of the data. Okay. And then, as I was saying, if you don't have a good input, you're not going to have a good output. That's as simple as that. So the regular terminology that all of us have heard here and there, garbage in, garbage out, no data better than bad data, is really true when it comes to AI ready data. And by the way, my background is in astronomy. So as an astronomer, we used to really swear by no data better than bad data, because no matter how you look at it, any bad data will give a run for its money to any astronomer when they're trying to process it. So it's true even for an AI ready data. And then you need to then conduct an initial data curation so that you can have a high quality data with little inconsistency. So you want consistency in your data set so that you're able to pass that on to your models. And then they are able to learn from those data set in a consistent way. So you need to make sure that there is a theme of consistency in your data sets. And then, as some of you have already alluded to, that yes, your data needs to also abide by fair data principles. Okay, so it has to have a data management concept. And then, as I said, the quality of your output will really be dependent on the quality of your input. So the better your input is, the better your output is going to be. And because this is an AI-ready data, the third step in this journey is thinking about metadata. So you need to have this present with your AI data, because you need to be able to provide the right context to the model, to the AI tool that you're trying to develop using that data set. And then in addition to that, based on the type of your AI use. So for example, if you're working with an AI agent or thinking about something with a Gen AI type of project, then you're now thinking about reducing the gaps that might be present in any textual data that you're dealing with, or identify gaps or language issues that might be relevant for your Gen AI case. Okay, so it really depends on what type of problem you're trying to solve, what type of data you have access to, where it has come from, and what context it is giving you that you need to be aware of. And then once you have these elements put together, the next thing is to think about how you can make it accessible to your group members or across your organization if you're doing it at a larger scale, which means that now you're thinking about that your data should be able to live in a centralized location. And because you're thinking about a central location, you're now also thinking about its overall formatting or its overall standardization. Can this be put in a format that is easily accessible to other folks from who may not be in your group or who may not be in your division, but maybe outside of your division, but still can would like to use that data. So that is where these additional layers start to come in when you're thinking about AI ready data. That how can you take it at that organization level? And in terms of the structure of the data itself, so this is where I would feel that it's slightly different from how you would envision the data for an ML case, or ML ready data. So typically thinking about ML ready data, we're thinking about a tabular format, we're thinking about a structure in that sense. In AI ready data, it could be tabular, it could be textual. The structure that is most relevant is whatever the theme is, it should be able to propagate. So for example, if you're thinking about a tabular data, the table should be clean and complete. That means you should have done your homework in terms of figuring out if there are any nans or if there are any edge cases in your tabular data that needs to be taken care of. But then your entire tabular data set should be consistent. Okay, so that is the kind of structure we're thinking about. On the other hand, when you're thinking about a document type data, textual data, you're thinking about consistent templates or sections. Again, some sort of a consistency. It doesn't mean that every section needs to have a similar type of subsections or that kind of a format, but the overall format of the document should be able to flow through if you're trying to use this for a Gen AI type of case. Okay, so that structure, that is what I mean by structure here, which is a little different from an ML ready data set. So that structure should be there, the consistency should be there. Then in terms of your overall format of the document itself, it should be in a way that it is machine readable, right? And it also has what we call as interoperable format, that you need to have your files in a certain format so that they can easily be accessed by others and also are machine readable. Okay, so these are the way you're thinking about in terms of organizing and formatting your data set. Any questions? Okay. So along those lines, then you are now thinking about data governance. That when you are working with these kind of data set, you need to make sure if they come with any sort of compliance, security compliance issues or not. So for example, if you are working with a PII type of data set, they need to be anonymized right from the get-go so that the information does not propagate. Similarly, one needs to be aware of whether these are, the CUI types or HIPAA compliance. All those kind of requirements need to be well thought out beforehand, right? So this is all in the data preparation stage itself. Okay. Now, once you are able to do all of these steps, you get to a point where you can then establish best practices around AI ready data. So what I mean by that is you can then get into the habit of, let's say, having a pipeline that is already ready, which can then automate, let's say, for example, processing your document or any other tools to transform a certain tabular data, let's say. So you could have that kind of a pipeline built once you have worked through these stages. Similarly, you can then start standardizing the templates, or you can start standardizing the tabular data format once you have identified that this is the format which will work the best for my research group or for my division or for my organization based on the type of AI use case you have at hand. Similarly, you need to be able to automate your data inspection. You need to have some data inspection policy that you can automate because this is, again, very important as the quality check or any sort of alerts that will tell you that the quality has gone down or there is something missing from the new data. All of that should be automated, because if you don't do that, it is very easy for all of this kind of a data to fall through the cracks. So in order to avoid that, there has to be that sort of an automation that will alert you on the data quality itself. And then let's say if you're working with documents, you can think about either building some knowledge graphs or semantic layers for the documents. On the other hand, if it's a tabular data that you mostly are used to working with, you can think about a data catalog, any place where you could have some sort of a master doc or a master table, let's say, or call it as a single source of truth that you can formulate. So all of these will still form part of your best practices in terms of getting your data AI ready. Okay. And what is really important is after having done all of this, you need to be able to continuously review the input data set. So once you have prepared your data following all these steps, your final step, which is also a very important step, is that you need to be able to review it. So you should have policies in place that lets you do it. So for example, a way to continually monitor your model's input and also outputs to verify if the results, it's giving you results as expected or not. Similarly, you need to have some sort of a data quality evaluation metrics put in place that can check for completeness or accuracy or consistency. And on top of it, the timeliness. And by timeliness, what I mean is you need to make sure that you are using most up-to-date data for your problem at hand as input. And it's not very outdated, which means you need to be able to define what is the duration that will be considered as most up-to-date. Okay, so all of these things should go into your AI-ready data preparation. Next, Sarah. All right. So so summarizing whatever I've said so far, what I would consider as key characteristics of an AI-ready data is something that has high quality and is clean, which has a structure and also the right context for the problem at hand. The context for one problem may not be relevant for a context for another problem. So which means that you need to understand the problem to be able to provide the right context to it. And of course, it's something which is also governed and secure. So you need to be aware of the governance policy of not just of the data, but also of your own organization. What kind of data security level your organization follows. So you need to be aware of all that if you're trying to automate some of these processes. And then it needs to be aligned with the use case, the problem at hand that you're trying to solve. For example, if you are trying to predict a demand versus detect an anomaly, the data set and the context is going to look very different compared to if you're trying to just summarize key points from a paper or from a user doc, right? So all of that needs to inform how you will best prepare your data set for AI. And then it should lend itself to a faster AI deployment. And by that, what I mean is that it should be able to, it should be easy to digestible, machine readable format so that whatever data pipeline you build, they are there to just accelerate the development of AI solution. You're not investing too much time in just preparing your data to be AI ready. So once you have essentially followed these steps, you are at a point where things are mostly automated so that you accelerate the development of your AI solution. And then finally, it should be accessible and scalable because, as I said, it is something where you could integrate it into other AI workflows depending on the type of data you have prepared for your AI use case. And not only that, you bring it to a point where it's accessible to other people in your organization if they need it to be, which is sort of along the lines of data democratization. So what I'm showing here is, and this is a slide that I've borrowed from our work at the AI Facilitation Material Working Group here at CaRC, is essentially some of the stages that will go under data preparation, generalized data preparation, some of the key tasks that would be relevant for it, along with the tools that one can use to get that going. Now, this is still a very much, think of it as a analytical data preparation slide. So there's all the additional layers that I talked about are not captured here. That's just because these are the key tasks that anyone will have to go through in order to do the initial data preparation. So that's kind of what I'm trying to highlight here. So, starting from data cleaning, where you're now thinking about any sort of deduplication or handling outliers or missing values or nans, to thinking about your data quality, which means that you need to be able to remove bias. You need to be able to check for completeness. And as I said, it should be consistent throughout. So that consistency needs to be checked for. Privacy, again, thinking about if there are any PII type of information, how to anonymize all of that. So those type of things need to be taken care of. And if you are working with, let's say, a tabular data, then you're thinking about maybe transformation of those, some of those numerical columns, let's say. Or if if you have an audio or image type of data, then you're thinking about maybe augmenting some of the data there. So depending on the problem at hand, the relevant transformation that needs to take place is essentially what is being captured here. And then before you start with your major analysis, performing a typical EDA is a good step forward, because that will also tell you if there are any kind of anomalies that might have still, that might be still present, or just to get a feel for your overall distribution of, let's say, a tabular data set. And then, in some cases, doing that feature engineering might also be important, because not every AI case has to be a Gen AI case, right? So in certain AI cases, you will still be thinking about the right features that need to be engineered and added to your data set. So then, those are the tasks that would be relevant here. And then finally, again, in terms of, abiding by the FAIR principles, making it accessible to everyone. So thinking about data democratization, you are also thinking about reproducibility and versioning as a final step, which can capture your data transformation and versions. This will also help you and propagate your metadata forward, because now you're trying to build history with your data set. Okay, and this again is something that I borrowed from this work, from our work at AI Facilitation Material Working Group, which is just highlighting typical examples. So I have intentionally tried to not just highlight the Gen AI type of cases, but broadly AI ML cases that would be relevant for for a AI ML project lifecycle, and will benefit from this kind of AI ready data analysis or steps that I just laid out. So for example, if let's say you are trying to clean and curate a global record of 4.3 billion tweets, which includes time, geography, and language. So they're called geo tweets. So, if you have that kind of a project at hand, where you have this geo tweets as your input data set, and you need to perform sentiment analysis using natural language processing, then those are some of the steps you would be following to get your data AI ready. Okay. Similarly, if you need to convert the raw sequencing data into a tabular format with gene level counts, and so those are the steps that I just showed you in the last slide, will be the steps you will be following to prepare your data for that analysis. Similarly, introducing a labeling scheme for a behavioral sensor data, and then parallelizing the annotation workflow. So all of these examples are there, which will tell you that the data preparation needs to follow a certain step. And when you are doing this data preparation, that is also the stage where you are thinking about the cost model for your entire project, including data preparation, because you're thinking about or you're evaluating the cost of preparing the data and then downstream storage requirements, analysis requirements for on-prem versus cloud computing versus your local device that you have at disposal. So all of that information or all of that decision making process also happens pretty much at the data preparation stage when you're trying to get your data AI ready. Questions? Okay. So now that we've gone or looked at all these steps that are included for getting your data AI ready, I thought it'll be also good to sort of highlight how to think about your traditional data quality versus AI quality. And when you are thinking about traditional data quality, you are typically thinking about your data set should be clean, deduplicated, it should be consistent, should not have outliers. If you need to remove this, should not have nans, things like that. So for example, an example of such a case would be if I want to predict the wait times for the jobs that come to a cluster, um, then in that predictive analysis, it's a typical ML case where I would just need clean and accurate data set so that I can do my training and testing. And then once I have validated it and tested it, I'm ready to make predictions. Okay. I don't care about any other context other than making sure that these main things, including the feature that I need, are there to make the predictions. All right. However, if I'm now thinking about an AI case, I do think about context. All right. So thereby, AI quality is not just high quality. It means few more other things. So AI quality would mean that it should be your data set, A, should be representative of some real pattern. It could also include noise or edge cases. It's totally fine. And the additional need for AI case is it should have the context, which means you're now providing labels and annotations also. It needs to have metadata so that it has some sort of historical information of the data set, which you don't care about when you're thinking about traditional predictive analysis, let's say. And then if you're thinking about Gen AI cases, then now you're thinking about, hey, what is the quality of my prompts? Do I have a definition of what a good output should look like from my AI model that I have put together? So all of that is necessary. So having just a good training set is not enough. You need to have these additional things attached to that, or at least you need to be mindful of it. And then, for example, if you're now thinking with or working with a RAG-based AI agent, then you need to make sure that whatever documentation you're providing to your agent is up to date, it is relevant, it's clean, and whatever information you want to pass on to others through your RAG pipeline is conveyed properly, right? So a lot of emphasis is now given on the quality of your input documentation itself, right? And then similarly, as I said, your prompts, you have to think about prompts means you are now thinking about a little bit about structuring the prompts in the right way, giving it the right context so that your agent is able to work based on those prompts or those instructions that you have provided. So high quality alone is not AI ready. And then after doing all this, the other question that could come to my mind, because it did come to my mind, is why prepare data at all for AI? Like if it has so many things involved, what am I gaining at the end of the day by preparing my data ready for AI? So first of all, if I'm in the business of developing an AI model and making sure that it also gets deployed or put in production, I need to make sure that it is reliable, right? So if I prepare data which I can call as AI ready, I'm enhancing that reliability. Reason being that if I make sure my data has the right quality, has the right accuracy, then it means it will perform better, it will predict better, and which means that my overall deployed models will be reliable. Also, it helps with accelerating your AI projects. So now, once you have put this kind of a AI ready data pipeline together, you are spending less time on preparing your data, which means you are developing faster and putting your models to production faster. This also helps with reducing the failure rates for your AI projects, because a lot of times when you start on an AI project, if you are not cognizant of your data quality, it will end up failing just because you are not getting the output you were expecting. And a lot of times that happens because the data was not what it should have been. So there is the failure prevention rate. And another thing is it forces you to be in some sort of an ongoing process of ensuring that your data always meets the right quality. So now you're thinking about having an effective CI/CD pipeline, which will involve monitoring your data and enhancing your data, or making sure that it is timely, which means it is fresh enough for making decisions. So you kind of get into that habit of checking your data very constantly, which may not happen otherwise if you're not really worried about it too much. And then because you want to get it uh, in a proper AI ready data pipeline, you're already thinking about centralizing it, right? So that it is accessible to others if needed, which means now you're reducing data sprawl. There are no fragmented data or no data silos, and that also helps with data democratization overall. And it also forces you to make sure that you're not duplicating your data everywhere else, because now things are in a more centralized location, which means that it reduces your governance and cost related problems. So there are all these benefits if you are mindful of how to get your data AI ready. And then along those lines, you also have to think about making sure that it follows a consistent data quality management practice, which Sarah will be talking about a little bit more. But your overall organization of the data pipeline itself will force that data quality management practice is instilled in your workflow. And then, as I sort of alluded to before, that when you are getting your data ready for AI, you're thinking about a standardized format. You're thinking about that it is complying by the governance and security model of your organization, and whatever constraints or requirements the data itself came with throughout the AI lifecycle. And let's say if you are working with any LLM-based application, then you are also thinking about securing your data from any sort of a data leakage or any attacks that could happen through prompt injection. So all of these things will again help in making sure that your final model is a reliable one. And as I already mentioned in the beginning, that doing all of this also introduces best practices in a research group or in an organization, because a lot of CI/CD pipelines would have been built, a lot of automations would have already been done, and you would have been mindful of any security requirements or governance and compliance requirements from the very get-go. In addition to that, now there is the latest buzzword, which is around the zero trust data governance, which is that we cannot assume that any data is safe or human generated, which means we need to be in the habit of constantly verifying and controlling any sort of misinformation. So that is another thing that gets introduced when you're thinking about AI ready data from the very get go. And another good practice, which is, I would say, it's a standard practice for any HPC based workflow, and the same is applicable for AI based workflows as well, is to do few dry runs, right? So you start with one or two small AI projects, refine your data set, refine the patterns around it, build the pipelines, and put it into production. So you're able to work on small one or two AI projects end to end before going bigger. So that's kind of an easier way, which is essentially what we also tell our cluster users, that before putting anything into production, try to do some dry runs. So it's sort of along those same lines, that these are the things that you can do in order to get it to an AI ready format. And with that, I'll give it to Sarah.
All right, thanks, Manasvita. Yeah, I'll try and wrap up so we have a little bit of time for questions, but I just have a few remaining slides. So we talked at the beginning of the presentation about the benefits of AI with research. So there are some tools I wanted to highlight that can help with other aspects of your research besides just that data curation that Manasvita was talking about. So these are some of the common tools that you can use for like creating slide decks or images or other research products. They can help with writing, like Research Rabbit, Elicit, Cite, and others. They can help with grammar and citation and paper generation. And then if you're creating other materials like code, you'll also be able to use tools like GitHub Copilot that can help with generating code. So I just wanted to highlight those few tools as well. And then one of my core responsibilities as a data manager is to help researchers with identifying, comprehending, and selecting the right storage for their research. So storage for AI-ready data is slightly different than traditional data storage. It does need to be adaptable, so it has to be able to integrate with various research requirements that are rapidly changing. It has to be scalable to accommodate the exponential growth of research data that's generated through AI and ML workflows, which are generally larger data sets than you'll see with traditional science. It has to accommodate different data types and meet the rate of acquisition. And we found that this is sometimes more difficult to accommodate than just simply the total amount of storage needed. It's can we get that large amount of data into the storage continuously? It has to be efficient, so it has to have high read-write speeds, parallel processing, immediate connectivity to HPC environments. It has to be reliable, so it has to be constantly running, so no downtime, while also meeting the requirements of funding agencies in regards to data security and privacy. So if there's secure data, we have to make sure that it has the additional privacy setups in the storage itself. And then it has to be versatile, so it has to work with different tools, again, constantly evolving and needing to be updated over time. And lastly, I do think it's important to clarify that preparing data for AI is a team effort. So it does not just fall under your IT team or your research computing group or even just the researcher's responsibility. It's really a collaborative and coordinated effort. So no one entity at the university is responsible for AI ready data. I've included a few examples from our university on the slide of who's usually involved in these types of efforts, but that could be research administration, research computing, your IT office, your security office, the labs themselves, the researchers, but it also could be other entities like your library could also be involved to help with data collection, curation, storage, and data sharing. So it's always good to keep in mind that this should be a collaborative effort. So in summary, again, AI offers many benefits to academic research. It can help with data curation, executing repetitive tasks, predicting trends, and developing research products. But it also comes with inherent risks like plagiarism, unconscious bias, hallucinations, and intellectual property concerns. AI-ready data is achievable. You can have AI-ready data by creating high-quality, clean, and contextualized data sets. which can enhance reliability, data quality, accelerate your projects, streamline your pipelines, and help to reduce potential security risks. And there are tools out there that can help with other aspects of your research, including data preparation or generation of research materials. When thinking about storage, you really need to think about it differently from standard data storage. It requires further consideration to make sure you're selecting the appropriate option. So it should be scalable, reliable, and adaptable. And then preparing data for AI is a collaborative effort across your university. So that is it. I hope we do have a little bit of time for questions and comments. I'm glad you all were in the chat. Maybe we can stop the recording and then.
I just wanted to add that after this, we've added some supplemental material. So if you are willing, take a look. So Sarah, if you can just run through that. The first one is on the a typical example. I'm not going to go through that. And then there's a glossary of all the data related stuff that is out there and people talk about it here and there. So we just try to capture that and then put like one-liner definitions against each of those terminologies. That's it. Thank you.
Well, thank you very much. I am going to go ahead and stop the recording.